When working with knob and tube wiring, selecting the correct hole size for passing the wires through new framing is crucial for safety and code compliance. This guide provides recommendations for hole sizes based on the number of wires, along with a step-by-step process for drilling and securing the tubes. Generally, for 1 to 2 wires, a 1/2-inch hole is recommended. For 3 to 4 wires, use a 3/4-inch hole. And for 5 to 6 wires, a 1-inch hole is recommended. Remember, these are general guidelines, and you should always verify that the hole size is adequate for the specific wires you are working with. To begin, firstly, determine the number and size of wires inside the existing knob and tube. Accurately count the wires and visually assess their size to ensure proper hole selection. Secondly, select the appropriate hole size based on the guidelines provided. Choosing the right size is critical for preventing damage to the wires during the relocation process. Thirdly, mark the hole locations on the studs or framing where the new junction boxes will be located. Use a pencil to clearly mark the points where you intend to drill, ensuring they align with the planned wire path. Fourthly, drill the holes using a drill bit that matches the selected hole size. It is helpful to drill at a slight upward angle to facilitate easier insertion of the tubes. Fifthly, lubricate the ends of the tubes with petroleum jelly or soap to reduce friction. Carefully feed the tubes through the drilled holes until they reach the new junction boxes. Sixthly, once the tubes are correctly positioned, secure them to the studs or framing using cable staples or other appropriate fasteners. This will prevent movement and ensure the wires remain safely in place. Here are some additional tips. If possible, avoid drilling directly into the studs to prevent weakening the structural integrity of the wall. Aim to drill between the studs whenever feasible. Use a level to ensure the holes are drilled level and parallel to each other, maintaining a neat and professional appearance. If any wires are exposed during the process, immediately insulate and protect them using electrical tape or wire nuts to prevent accidental contact. Consider using a fish tape to assist in pulling the tubes through the holes, especially if the runs are long or difficult to access. This can simplify the process and reduce the risk of damage. Always exercise caution when working with electrical wiring. If you are unsure about any aspect of the process, consult a qualified electrician. Knob and tube wiring is an older type of electrical wiring that was commonly used in homes built before the 1940s. It consists of single insulated wires run through ceramic knobs and tubes. While knob and tube wiring can be safe if properly maintained, it is important to be aware of its limitations and potential hazards. The insulation on knob and tube wiring can deteriorate over time, which can increase the risk of electrical shock or fire. It is also important to ensure that knob and tube wiring is not covered by insulation, as this can cause the wires to overheat. If you have knob and tube wiring in your home, it is important to have it inspected by a qualified electrician to ensure that it is safe and up to code. If you are planning any renovations that involve knob and tube wiring, it is important to consult with an electrician to determine the best course of action. In some cases, it may be necessary to replace the knob and tube wiring with modern wiring. When drilling holes for electrical wiring, it is important to follow the National Electrical Code, or NEC, guidelines. The NEC provides specific requirements for the size and spacing of holes, as well as the type of wiring that can be used. The NEC also requires that all electrical work be performed by a qualified electrician. When working with knob and tube wiring, it is especially important to be careful and to follow all safety precautions. Knob and tube wiring is an older type of wiring that is not as safe as modern wiring. It is important to have it inspected by a qualified electrician and to follow all safety precautions when working with it. Here are some additional safety tips for working with knob and tube wiring. Firstly, always turn off the power to the circuit before working on any electrical wiring. Secondly, use insulated tools when working with electrical wiring. Thirdly, wear rubber gloves and eye protection when working with electrical wiring. Fourthly, never work on electrical wiring when you are wet or standing in water. Fifthly, if you are not comfortable working with electrical wiring, hire a qualified electrician. When running wires through bored holes in wood framing members, protection against the edge of the hole is required. This protection prevents damage to the conductor insulation. Section 300.4 of the NEC addresses this topic. Where subject to physical damage, conductors must be protected. Let's delve into the specific requirements outlined in Section 300.4. Firstly, bored holes. In both exposed and concealed locations where a cable or raceway type wiring method is installed through bored holes in wood framing members such as studs, joists, or rafters, the hole must be bored so that the edge of the hole is not less than 1/4 inch from the nearest edge of the wood framing member. Where this distance cannot be maintained, the cable or raceway must be protected from penetration by screws or nails by a steel plate or bushing. This plate or bushing should be at least 1/16 inch thick and of appropriate size to protect the wiring. Secondly, notches. In both exposed and concealed locations where a cable or raceway type wiring method is installed in notches in wood framing members, the notch must be covered with a steel plate or bushing to protect the cable from penetration by screws or nails. The plate or bushing should be at least 1/16 inch thick and of appropriate size to protect the wiring. Thirdly, non-metallic sheath cable and electrical non-metallic tubing. When non-metallic sheath cable or electrical non-metallic tubing is used, it must be supported and secured to the wood framing member within 12 inches of the point where it enters the hole or notch. In addition to these general requirements, there are some specific rules for certain types of wiring. For example, for non-metallic sheath cable, the NEC requires that the cable be supported and secured to the wood framing member within 12 inches of the point where it enters the hole or notch. For electrical metallic tubing, the NEC requires that the tubing be supported and secured to the wood framing member within 3 feet of the point where it enters the hole or notch. It is important to note that these are just the minimum requirements of the NEC. Local codes may have additional requirements. It is always best to check with your local building department to ensure that you are in compliance with all applicable codes. The purpose of these requirements is to protect the wiring from physical damage and to prevent electrical shock. By following these guidelines, you can help ensure that your electrical wiring is safe and reliable. Always consult the latest edition of the NEC and local amendments for the most up-to-date regulations. Proper electrical work requires a thorough understanding of these codes and best practices. Now let's discuss how to interpret and apply these rules effectively. Firstly, identifying framing members. Accurately identify the wood framing members such as studs, joists, and rafters in your construction. These are the structural elements through which you will be running the wiring. Secondly, measuring hole edge distance. When drilling holes, meticulously measure the distance from the edge of the hole to the nearest edge of the wood framing member. Ensure this distance is at least 1/4 inch to avoid the need for protective plates or bushings. Thirdly, installing protective plates. If the required 1/4 inch distance cannot be maintained, install steel protective plates or bushings. These should be at least 1/16 inch thick and large enough to completely cover the wiring at the point where it passes through the hole or notch. Fourthly, securing wiring. Secure the wiring to the wood framing member within the specified distances. For non-metallic sheath cable and electrical non-metallic tubing, this is typically within 12 inches of the hole or notch. Use appropriate fasteners to ensure the wiring remains securely in place. Fifthly, verifying compliance. After completing the wiring installation, double-check all measurements and protective measures to ensure compliance with the NEC and local codes. It is always better to be thorough and ensure safety. Here are some additional tips. When drilling holes, use a drill bit that is slightly larger than the diameter of the wiring or conduit to allow for easy passage and prevent damage to the insulation. When installing protective plates or bushings, ensure they are securely fastened to the wood framing member to prevent them from shifting or falling out. When securing wiring, use fasteners that are appropriate for the type of wiring and the material of the wood framing member. Avoid using nails or screws that are too long, as they can penetrate the wiring and cause damage. Here is an example. Imagine you are running a non-metallic sheath cable through a stud in a wall. You drill a hole through the stud to run the cable through. However, the edge of the hole is only 1 inch from the edge of the stud. In this case, you would need to install a steel protective plate or bushing to protect the cable from penetration by screws or nails. The plate or bushing should be at least 1/16 inch thick and large enough to cover the cable at the point where it passes through the hole. By understanding and following these NEC guidelines, you can ensure that your electrical wiring is installed safely and in compliance with code. Always prioritize safety and consult with qualified professionals when necessary.